Okay, so we are gonna do some of the problems from the 10th extended edition of Fundamentals of Physics, edited as Resnick and Walker, as mentioned by all of you. Um, so here's problem 3. So you can find exact statements from the book. So I'll just go through the minute details of problems. So in this problem, the x component of a vector is minus 25 meter and y component is 40 meter. So vector ax is minus 25 meter and the y component is 40 meter. So we have to find magnitude, that is magnitude of vector A, and the angle theta which this vector makes with the positive x-axis. Um, so if I have to draw the components of this given vector on the two-dimensional Cartesian coordinate system, then this will be x prime, this is our y, this is the negative y-axis, and this vector will lie in this direction. So, so this is minus 25 and 40. So these are the coordinates. This is the length of the vector. And we have to find this angle theta. So this is quite an easy problem to find the magnitude of a vector. We just have to take this the square of the components and then find the square root. So a equals ax square plus a y square. So this in turn will yield, so by putting the values, minus 25 square plus 40 square, a will be 4.72 meter. In the same uh, so now we can find angle theta. Theta equals tangent inverse ay over ax. That is tangent inverse 40 over minus 25. Theta will be minus 58 degrees. But we know that tangent theta is also equal to tangent theta 180 plus theta. So another angle can be found. Let me call this theta 1 or whatever you want to say. So 180 plus, by the way, let me call this theta rather than theta prime. So this is 122 degrees. So these are our right answers. So the magnitude is 4.72 meter, and the angle theta, whether it will be minus 58 degree or it will be 122 degree. So both angles are equivalent. And so this is our first problem. And now we'll do problem number 8. See where it is now. So problem number 8. So let's see what we are given in the question. So this problem states that a person walks in the following pattern. So let me call this vector A, 3.1 kilometer north. So let me call this capital N. Then a vector B, 2.4 kilometer west, and a vector C, 5.2 kilometer south. So first of all, we have to figure out this descriptive statements into a mathematical equation. But to do this, we have to draw an equivalent Cartesian system of these directions. So as we have seen in the class, This is called east, this is west, this is our north, and this is south. So by using the terminology from the unit vectors, this is positive I, this is minus I, this is plus j, and this is minus j. So I can write this equation as 3.1 I hat. I'm not gonna write the units. Sorry, this will be 3.1 kilometer in the direction of j hat, and this will be 2.4 kilometer minus I hat, and this will be 5.2 kilometer minus j hat. Or if I have to uh, uh, draw the schematic diagram of the journey of the particle, then it will be something like this. So this will be vector A. So let me use some other color. This will be vector. So this diagram is not drawn to scale. Yeah, and this will be vector C. So this is our starting point, and this is our final point. So we have to find. This is our the vector diagram. So it is also set to draw this diagram. So we have to find how far and in what direction would a bird fly in a straight line from the same starting point to the same final point. So technically we have to find this vector. So let me call this vector R. So this is our resultant vector. Okay, so to find this resultant vector, we can just add all of these vectors, A plus B plus C. So ith components will be added into ith components, and the jth component will be added into the jth components. So this will be so we have only one I component, so that will be minus 2.4 I hat. Again, I'm not gonna write the units. Minus 2.1 j hat. So once the vector is given, we can easily find out its magnitude. That is rx square plus ry square. So which is minus 2.4 square plus minus 2.1 square. Sorry. So now r will be mm, roughly equals to 3.2 kilometer. So this is the total distance that will be covered. So basically, this is the displacement that will be covered by the object. So now we can find the angle theta, that is in which direction this bird will fly. Theta will be tangent inverse ry over rx, tangent inverse is so minus 2.1 minus 2.4. So theta will be 41 degree, or theta will be 180 plus 41 equals 221 degree. Pardon me if I forgot to write these degree signs. So this will be our answer, and this will be our answer. And plus this is also our answer. Let me just box it. I will be box. So this is problem number 8. So next we have problem number 11. Let's see what this is. Oh, okay, this is problem number 11. Let's do this. So problem 11 states that in unit vector notation, what is the sum a plus b if a and b are given? So what are the magnitude and the direction of a plus b? So this is problem number 11. So we are given vector a, which is, for I'm not gonna write the units, plus 3j, um, and vector b is minus 13 I plus 7j. So we have to find a plus b. We have to find, uh, so let me call this vector r. So we have to find r and we have to find theta. I think this is quite easy to do the problem. So to find r, you just have to add the x components and the y components. So ax plus bx I have. This is from the vector resolution. You already know this thing. Plus ay plus by j hat. So ax plus bx 4 minus 13. So that will be minus 9 I hat and plus 10 j hat. So this is, so now I can write this as a plus b. In the same fashion as we did earlier, we can find the magnitude. So this will be minus 9 square plus r will be equals, so approximately equals 13.4 and in the units of meter. And theta will be tangent inverse ry over rx, tangent inverse 10 over minus 9. Theta will be minus 48 degree, or theta is equal to 180 plus minus 48. Theta will be 132 degree. This is what we have to do in this problem. So let me just box the answers. So this is our first answer, and this is the magnitude of a sum. Uh, this is one possibility of the angle, and this is another one. So you know that this angle can be drawn from the negative x-axis, while this is from the positive x-axis. So this is problem number 11. So in the next in the list we have problem number 14. That's a good problem. Okay. So the statement is quite lengthy, so I'm not gonna read it. You can just find the statement from the book. Just let me write down the main points of the problem. So let me restate this. So there's an object which is used for different trajectories, or which is for different stations to reach a final point. So let's suppose he has to reach a point D, but he has the trajectory that the particle is gonna fall in A to B to C to D to E. So this will be the journey. So say the particle, so it is given that the particle has to reach at minus 140 and 30. So these are the coordinates of the particle, or the final position. So but the particle takes the following journey to reach this point. So let me call these points. A is 2060, B bx, so this is unknown, minus 70, C minus 20, cy, d minus 60, minus 70. So we can say that this point P is the resultant of all of these 4 points. And you know that this is an ordered pair, so x is positive, y is positive, which means that this point lies in the first quadrant. So in this point, both are negative, so this will be in third quadrant. While in these two ordered pairs, we do not know what are the magnitudes of the bx and cy. So at the moment, we cannot say what will be what will in which quadrant these coordinates will lie. But we have to find bx and cy. So you can just use same terminology. That is the x component of the resultant vector. Let me call it px will be equal to ax plus bx plus cx plus dx. So px is equal to minus 140. Ax is 20. Bx is unknown. Minus 20 minus 60. So by solving this, we get bx equals minus 80. In the same fashion, we can find by ay plus by plus cy plus dy. So py is 30 and ay is 60 minus 70 plus cy minus 70. So cy will be 110. So these are the two unknown points. So next we have to find the total distance covered by the object. That is, we have to find the length of this point P. So let me just do that stuff with a different color here. So I'm just gonna write the formulas. So P equals to px square plus py square. Just by put the values and we'll get an answer of around 143 meters. So all these coordinates are given in meter. Theta is equal to tangent inverse 30 over minus 140, and you will get an answer of minus 120 degree, or theta is equal to tangent 180 degree plus minus 120, which is equal to 60 degree. Let me just box this thing. This is one answer, this is the one solution of angle, and this is another solution of angle. Sorry, I think I did a mistake. So this is one. This is 12 degree, and in turn this will be 68 degree. Yes. Okay, so this is problem. This is problem. It's fine. So next we have problem number 15. Okay, so now we have problem number 15. Um, so let me draw the diagram first. Um, this pardon me for the very rough diagram. So this is our coordinate axis. This is x. This is origin O. This is y. So this is our first vector A, and this is angle theta 1. I'm gonna extend this vector by this dash line. Now I will draw the vector B. This vector B is given in this direction, and this is the angle theta 2. That is the angle which vector B makes with the vector A. Okay, so it is given that both vectors are of equal magnitudes, that is A equals 10 equals B, and the respective angles are theta 1 equals 30 degree and theta 2 is 105 degree. So the problem is quite simple, but we have to indicate, or we have to find what is the angle that both of these vectors are making with the positive x-axis according to the convention of right-handed coordinate system. So we can easily figure out that the, the angle theta A, that is the angle which vector A makes with the positive x-axis, is just equal to theta 1. So that is, this is 30. But the angle theta 2 is not the angle which vector B makes with the positive x-axis, while this is the angle between theta 1 and theta 2. So we have to find what will be the angle theta. So what will be the angle theta B is. So this is my x-axis, And this vector A, this is just the extension of vector A, and it makes an angle of theta 1 with this line, with this with this x-axis. Okay. So it is quite evident that this will be the angle theta b, which this vector b will make with this positive x-axis. So theta b should be equal to theta 1 plus theta, let me call this theta b. So theta b should be equal to theta 1 plus theta 2. That is 30 plus 105, which is 135 degree. I hope this will be now clear to you what will be our angle. And so once this is clear, and then it is quite easy to find the rest of the coordinates, or rest of the components of the vector. So now we can find the resultant, the components of the resultant vector. So Rx will be A cos of theta A plus B cos of theta B. So we have the values of A, B, theta A, theta B. Just put it in the equation and we will get an answer of roughly 1.59 meters. Similarly, Ry will be A sine of theta A. This is just the vector addition via components, plus sine of theta B, and it will be 12.1 meters. So now we can find the distance, that is Rx square plus Ry square. Put all these values and you will get an answer of nearly 12.2 meter. And similarly, theta will be tangent inverse Ry over Rx. Just put the values here and the answer will be 82.5 degrees. So now again, let me box all of these. So this is the x component of the resultant vector. This is the y component. This is the total distance, and this is the angle. By the way, if I have to draw this resultant vector, so which color can I use? Let me use this orange color. So this resultant vector will somehow be like this. Basically, this is the resultant vector. Okay, and this will be the angle theta. So, and the next problem we have to do is problem number 34, 35, 36, and 40. So let's see. What is given in problem number 34? Oh, alright. And so in problem number 34, it is given. We are given with vector A 3I plus 5j, vector B 2I plus 4j. And first we have to find A dot B. So A dot B equals AX BX plus AY BY. Um, so this will be 3 multiplied by 2 plus 5 multiplied by 4. So A dot B will be 26. Sorry, this is part number B. So this is part B. And in part A, we have to find A cross B. So that can be found via 3 by 3 determinant I, J, K. So vector A is 3, 5, 0, 2, 4, 0. This will be K hat 4 multiplied by 3 minus 5 multiplied by 2. So this is 2 K hat. Remember, I use the following convention: plus, minus, plus. So these two will be 0 due to this 0th column. Null. Okay. So next we have part C. So in part C, first we have to find A plus B, then dotted with vector B. So I'm not gonna do this. You just have to add the two vectors, and by adding two vectors, we'll get um, 5i plus 9j dot 2i plus 4j, and the answer will be 46, whatever the unit is. Okay, so part D, that is quite important. So this was our answer. This was so in part D, find component of A along the direction of B. So what we have to find? We have to find A, B, the component of A along the direction of B. So AB will be equals to the dot product of vector A and the unit vector B. So unit vector can be designated as the vector over vector magnitude. So this will be just A dot B over B. So and you know how to find the magnitude of the vector B. So for example, B equals bx square plus by square. So that is 2 square plus 4 square. Just simplify it and you will get the answer of the vector B. So by putting this value in this equation, we will get AB equals 5.8, whatever the units are given in the problem. So this is how you can find the magnitude of, you find the component of A along the direction of B. So this is what was given in the problem. So next we have problem number 35. Is problem 35 states that we are given with two vectors R and S in the xy plane. Remember, in some of the problems, the planes are of extreme importance. We'll see in one of the problems. So these two vectors given in the xy plane. It means there will be no j component. So that is, these two vectors are perpendicular to the zth component. And the magnitude of R is and the magnitude of R is 4.50 and S is 7.30 units respectively, and the direction theta of R equals 320 degree and theta of S equals 85 degree as measured counterclockwise from the positive x-axis. So what are the values of R dot S and R cross S? Okay, so first let's draw the vectors. This can be vector r with this angle theta r. This can be vector uh, s. So this is as angle is 320 degree and it will be in the fourth quadrant. This is theta s. So we have to find the angle between these two vectors. So both of these vectors are in the opposite direction and we have to find this angle. So either we have to move from negative y-axis to the positive y-axis or in which direction we want to move. So basically we have to find first of all theta. So theta will be 322 degree minus 85 degree and that is 235 degree. So this is just the difference of the angles as both of the angles are pointing in the different directions. Sorry, I have drawn theta as in a wrong way. So let me sorry. I have drawn theta as completely wrong. So theta s will be this angle. This is my theta s, which is 320 degree. So if I'm gonna draw this in this direction, then this will be 360 degree minus something. The value of this 360 degree minus 320 degrees. So that is it is around minus 40 degrees. That is equally fine. Okay. So this is r theta. So once we have theta, we can easily find r dot s, that is rs cos of theta. Just plug in the values and we'll get minus 18.8 as the answer. R cross s, rs sine theta n hat. Okay, so since both of these vectors are in xy plane, so from the right hand rule you can find the direction of the third vector, that is that will be positive positive z axis. The answer will be 26.9 k hat. So if you are unable to fetch the direction of the vector, let me know and I'll elaborate. So this is problem number 35. And we are only left with the two problems, 36 and 30 and 40. Okay. So problem number 36. So we are given with vectors d1 3i minus 2j plus 4k, vector d2 minus 5i plus 2j minus k. Right. And we have to find d1 plus d2 dot d1 cross 4 d2. So first of all we have to multiply vector d2 with 4. So 4 d2 will be minus 20 I hat. This is the multiplication of vector by a scalar number plus 8j hat minus 4k hat. And d1 plus d2 will be minus 2i hat plus 0j hat plus 3k hat. And d1 cross 4 d2 I j k. So d1 is 3 minus 2 4, and this is minus 20 8 minus 4. So this will be I hat into 8 minus 32 minus j hat minus 12 plus 80 plus k hat 24 minus 40. This will be minus 24 I hat minus 68 j hat minus 16 k hat. So we have found out both d1 plus d2 and d1 cross for d2. Now we can find the given vector. So d1 plus d2 dotted with d1 cross 4d2. So this will be minus 2 into minus 24 plus 0 into minus 68 plus 3 into minus 16. So this will give 0. So this is 0. By the way, this is also evident from another fact that so d1 plus d2 is in the plane, while since this is a cross product, so this will be out of the plane. That is, this is the perpendicular component. So whenever you try to dot a planar component with a perpendicular component, or this, so so let me let me write this component in a more visible or in a more conventional notation. This is parallel component. So whenever you try to dot a parallel component with a perpendicular component, answer will be 0. So that's also evident from the fact that we have not a mixed term like ex by or ay bx. So that is also clearly 0 from this fact. You don't even have to do any mathematics. So now we are only left with one problem. Problem 40. There's an interesting problem, and it will give a gist of different planes. So let me write some of the things from the problem. So we are given with a vector d1 whose length is 44.5 meters, and the angle that it makes with, let me call this d1, 63 degree. But this is the angle from the positive y-axis, and it has a positive z component. It is given in the box in the statement. So it means this vector lies in yz plane, not in the conventional xz plane. So if I have to find the vector d1, what I will write, d1 cos of theta d1 plus d1 sine of theta d1. Since this is yz plane, so I can write this component as j hat and this as k hat, not the conventional I plus j hat, because the plane is now yz plane. So by plugging the values, so theta d1 will just be 63 degree. So now in this plane we are finding the angle not with the positive x-axis but with the positive y-axis. So I do not have to plus or minus anything from the given angle. So just by plugging in the values, I will find d1 to be 2.04 j hat plus 4.01 k hat in the units of meter. Now the second vector d2, the displacement of the second vector is 1.40 meter, and theta of d2 is 30 degree from the positive x-axis, and the vector has an z component, so according to the statement. So this vector lies in the conventional xz plane, not in the xy plane. So we can find the components of the vector as d2 d2 cos of theta d2 d2 sine of theta d2. So now this component will be ith component and this will be kth component. So by plugging the values, we can find the vector. So let me write it here. So d2 will turn out to be 1.21 I hat plus 0.7 k hat meters. Now we can find any other thing that we want to calculate. So for example, if we want to calculate d1 dot d2, so you just have to multiply ith component with the ith, jth with jth, and kth with kth. So this will be like d1x, d2x, d1y plus, sorry, this will not, okay. So there is no ith component in the vector d1, so this will, so and there is no jth component in this vector, so you just have to multiply 4.01 with 0.7. You can easily understand this scheme. So this will be 2.81 meter square. Similarly, you can find d1 cross d2 as we did in the previous problems, and the answer will come out to be 1.43 I hat plus 4.86 j hat minus 2.48 k hat meter square. Now let me find the another quantity on this page. I don't want to use another whiteboard. So we have to find the angle theta between these two vectors. Theta will be cos inverse d1 dot d2 over d1 d2. Just find the magnitude of these vectors. So this will be a cos inverse 2.81 over 4.5 multiplied by 1.4. By the way, this is given here, this and this. So theta will be 63.5 degree. So this is the answer, this is the answer, and this is the answer. Okay. So these are all the problems that you have mentioned in the comments. Okay. Thank you.